Okay, so like imagine, right, a computer translating languages. But it's not just memorizing phrases, it's like actually understanding the connections between words, even if they're like super far apart.
Yeah, it's wild. That's the whole idea of attention in AI.
And it's kind of changing everything, isn't it?
For sure, it's way more like how, we understand language. Like we pick up on the little things, the context.
Totally. So that's what we're diving into today. This paper from Google, Attention is All You Need. This is the one that introduced the transformer model, right?
Exactly. And it like shook things up in the AI world big time.
Yeah, I can imagine. So to get why this was such a big deal, we need to go back a bit. Before transformers, there were RNNs.
Yeah, recurrent neural networks, they were like the go-to for stuff like language translation.
Mm.
But they had a big problem.
Okay, I'm curious. What was the issue with RNNs?
So imagine you're reading a book, right? But you can only read one word at a time. And you're trying to remember the whole plot in your head as you go.
Oof, that sounds rough.
That's what it was like for RNNs. They worked sequentially, so they were slow. And long sentences, forget about it, they struggled. It's like trying to remember something from chapter 1 when you're already like 10 chapters in. The further back the information, the harder it is to hold on to.
Right, right. It's like our brains can only handle so much at once. So then comes the transformer with its fancy self-attention, right?
Bingo. That's the key. The transformer looks at all the words in a sentence at the same time, and it figures out how they relate to each other no matter where they are.
Whoa, so it's not just going one by one. That's amazing. But how does it actually do that? The self-attention, it sounds kind of mysterious.
It's super clever, really. It uses these things called queries, keys, and values. It's kind of like, imagine you're looking at a picture. Your eyes, they kind of jump around, focusing on the important parts and how they fit together.
I see, I see. So it's like the transformer is creating a map of the sentence in its head.
You got it. It figures out which words are most important for understanding what's going on. It calculates these attention weights to do that.
Okay, that makes sense. So, for example, if the sentence is, the cat sat on the mat.
Yeah, exactly. The model might pay really close attention to cat and sat
Yeah.
to understand, like, that the cat is the one doing the sitting.
It's looking at the whole sentence, not just the words in order. Wow.
Yeah.
And that's what makes it so much faster than RNNs, right?
Totally, because it can analyze everything at once. Huge speed advantage. And it actually gets even more complex. There's this other layer called multi-head attention.
Multi-head attention. Okay, now I'm really interested. What is that?
So picture this. You have, like, a bunch of specialists,
Yeah.
right? Each one's an expert in something different, and they're all looking at the same problem, but from different angles. That's basically multi-head attention. Each head focuses on a different kind of relationship between words.
Ah, okay. So some might be looking at the grammar, others at the meaning, and so on, like a team of experts.
Yeah, exactly. And that's a big reason why the transformer is so much better than what came before.
I can see why this paper made such a splash. Okay, but here's something I'm wondering. If it's looking at all the words at once, how does it know what order they come in? Word order matters, doesn't it?
Absolutely. And they had a really smart way to deal with that. Positional encoding.
Okay, positional encoding.
Okay.
You've got to tell me more about that.
Basically, they use math sign and cosine functions to add information about each word's position. It's like giving each word a specific address in the sentence.
I see. So it knows cat comes before sat, even though it's looking at them both at the same time. That's pretty neat.
It is, right. It's crucial for the model to actually get the meaning right.
Okay, so it's analyzing everything at once. It's got these multiple heads. I bet that means it's also way faster to train than RNNs.
You're totally right.
Mm-hmm.
Because it can do all this parallel processing. It can train on huge amounts of data really quickly.
So smarter and faster. Wow, and I'm guessing the results were pretty impressive too. Did it actually beat the other models?
Oh, yeah. Big time. They tested it on machine translation, and the transformer just blew everything else out of the water.
No kidding. So it wasn't just theory, it actually worked. But did they just stop with one model? Or did they, like, experiment with different versions?
Oh, they did definitely experimented. They tried different sizes, different numbers of attention heads, all sorts of things.
It's like fine-tuning a race car. What did they learn from all that?
Well, they found, like, bigger models tend to work better. Big surprise there. But also, this technique called dropout helped a lot to avoid overfitting.
Dropout. What's that?
It's like, imagine you randomly remove some of the connections in the neural network while it's learning. It forces the model to learn more robust features. So it doesn't just memorize the training data, it can actually generalize to new stuff it hasn't seen before.
Ah, that's clever. So it's not just cheating on the test by remembering everything.
Exactly. And they actually found something pretty surprising, too. They tried making the attention keys smaller, thinking it would be faster. But it made things worse.
Really? I would have thought smaller would be better. What happened?
Well, it turns out figuring out how words relate to each other is a really complex task.
Yeah.
And those keys need to have enough information to do it right.
Okay, so sometimes bigger is better, even for attention keys. That's really interesting. So we've got this incredible model that's, changing how we do translation. But is that it? Is that all it can do?
Nope, not even close.
Mm.
That's the cool thing about the transformer. It's not just a one-trick pony. Researchers are already, figuring out how to use it for all sorts of data. Images, audio, you name it.
Yeah, that's what I was thinking. If it can understand how words connect, why not, pixels in an image or something?
Exactly. And they're already doing it. Like with image recognition, the model can use self-attention to zero in on the important parts of a picture, just like it does with words.
So instead of looking at each pixel by itself, it can see the whole picture, right?
Right.
It can understand that those pixels over there make up a cat's face.
Yep, that's the idea.
Yeah.
And it's leading to some crazy good results.
I can see how that could be a game changer. Imagine self-driving cars that can understand their surroundings better. Or medical imaging that can spot things that doctors might miss.
Oh, yeah, definitely. And it goes beyond just understanding stuff, too. It can also generate new data.
Whoa, wait. Generating data? You mean like AI creating its own pictures or music?
Exactly. Because it's so good at understanding relationships, it can use that knowledge to make new things. Imagine an AI composing music in a certain style, like jazz or classical.
So it's not just copying, it's creating something new. That's pretty mind-blowing. What are the limits here?
It's hard to say. People are pushing the boundaries all the time. It's not just music either. We could have AI generating realistic images, writing poetry, even whole movie scripts.
It sounds like science fiction, but this is all real, right? It's happening now.
Oh, yeah, it's happening. And it's all thanks to attention and the transformer.
This is seriously groundbreaking stuff. We've talked a lot about, the technical side of things, but I think we should also talk about, the implications. This is powerful technology, and we need to be careful with it.
Absolutely. We need to think about the potential consequences, both good and bad, and make sure this technology is used to benefit everyone.
That's a really good point. It's a responsibility we all share.
Okay, so we've looked at how the transformer works, what it can do, and why we need to use it carefully. What would you say is the main takeaway for our listeners?
I think the big thing to remember is this. The way we're teaching AI to process information is changing, big time. With self-attention, we're moving away from that, rigid step-by-step way of thinking. We're moving towards a more holistic, relational understanding of data.
Yeah, that's a good way to put it. It's not just about new algorithms, it's a whole new way of thinking about intelligence itself.
Mm.
And it kind of makes you wonder. We've been talking about how attention is changing AI. But what about other areas? Could it help us understand how our own brains work? Or how we're creative? Or even just how we interact with each other?
That's a really interesting question. Maybe the transformer isn't just a model for AI. Maybe it's a model for understanding all kinds of intelligence.
Yeah, that's something to think about.
All right, I think that's a good place to wrap up our deep dive into attention is all you need.
We covered a lot. From the nitty-gritty details of self-attention to the big picture stuff.
And we've only just scratched the surface.
That's what makes it so exciting, though, right? This field is constantly changing. There's always something new to discover, so stay curious.
It's crazy to think, right? Just a few years ago, this whole transformer thing was brand new, and now it's everywhere in AI.
Yeah, it's everywhere. I guess it shows you how powerful this self-attention idea really is. Who would have thought it could do so much? It's really impressive. The people who came up with this, they weren't just thinking about one problem. They wanted something that could be used for, all sorts of things.
And it seems like they succeeded. But one thing that stood out to me in the paper was how much they focused on efficiency. It wasn't just about being accurate. It was also about speed.
Oh, yeah, for sure. That's a huge part of why the transformer is so cool. It's not just smarter. It's also way faster to train.
Right, because of that parallel processing thing. It's like having a whole team of experts working on a problem at the same time instead of just one person doing it step by step.
Exactly. And that means we can now build much bigger and more complex models than before, which is leading to tons of new discoveries.
It's like we've given AI a super boost. But I think it's important to remember that with all this power comes responsibility, right?
Totally. As AI gets more advanced and starts playing a bigger role in our lives,
Hmm?
we need to be very careful. Like, how is this going to affect our jobs, our relationships, even our sense of self?
Those are big questions. And it's not just for the researchers to figure out. We all need to be part of the conversation.
I agree. We need to make sure AI is used for good. It's not about being afraid of it. It's about understanding it and making sure it aligns with our values.
Okay, so as we wrap up our deep dive into attention is all you need, what would you say is the most important thing for our listeners to take away from all this?
I think the key takeaway is this. The way we think about AI is changing. The transformer, with this self-attention mechanism, it's a whole new way of approaching artificial intelligence. It's a glimpse into a future where AI is not just a tool, but like a partner in helping us reach our full potential.
That's a great way to put it. It's a future with a lot of possibilities, but also a lot of responsibility. So to everyone listening, stay curious, keep asking questions, and be part of shaping the future of AI. Thanks for joining us on this deep dive.